All right. All right, good evening, everybody, and welcome. We have a nice full crowd here. I love to see that. Thanks for coming out on such a beautiful day. I know there's other places and things you can do, so we appreciate you spending some time with us tonight. So, any first-timers here? I asked that earlier before we started, so want to see more couple? All right, good. So my name is Michael Redlick. I'm one of the directors. Barry Bird is another director, and Paul Sire is way in the back. We have our leaders here, Diane. Come on, raise your hand, Diane. There you go. Garima. Who else is here from? Oh, Lay? Yes. And I think that's it. Okay. All right, so let's get started here. We got a lot to do tonight. So, okay, good. All right, so what we usually do, we thank our sponsors. We appreciate their support, so we always do that. Talk about what's new. I'm going to introduce Matt Flores, who's going to give a report on his, I said your name right? Yeah. Okay. He attended the Arc of AI, I guess that was last month, and he's going to report on that. And then after Matt's done, then we'll introduce Doug Drexel, and then he'll give his talk. And then afterwards, we'll come back. I'll do the closing slides on what's coming up and all that good stuff. All right, our gold sponsor is Pyara, makers of the Pyara platform, which includes Pyara Server, Pyara Micro, Pyara Cube, that's Q-U-B-E, and some other products that they have. So we appreciate their support, for running Jakarta EE applications. Azul is our silver sponsor, and some of you might ask, wait a minute, didn't one buy the other? And yes, that happened at the end of last year. So, we have both with us. Our partner is DevNexus, and for those of you who come here on a regular basis know that this is a conference in the springtime down in Atlanta, and it's run by the Atlanta Java User Group. Awesome conference. Barry, Chandra, myself, we've all participated in some way, shape, or form over the years. Great conference. Get to reconnect with all of our friends. And our per meeting sponsors is Romanelli's. They give us a big discount on the pizza, right? So we appreciate that. JetBrains is the company that makes IntelliJ IDEA, and I raffle off a copy of a one-year license once a month, and we'll talk more about that later. And then I mentioned here Jakarta EE. There is a Crowdcast, which is another hosting platform or video conferencing platform. They provide that for all Java user groups. We did use them for a while, and we decided to go with Zoom to live stream to YouTube. Our memberships are the Jakarta EE ambassadors. This goes back to when Java EE still existed, and the long story about Java EE 8 getting released. So, so we're part of that. We're part of the microprofile and Jakarta EE working groups, and then we're also part of the virtual jug. And we have new leaders, and they're both here. I introduced them already, so they just joined last month. So welcome. So yes, our leadership team has grown over the past few months, and Lay has done a lot of work on the website, cleaning up our profile picture poster, or pictures. And Garima's going to talk next month more about that coming up. So. This is good that we have a lot more help to do the things we want to do, with the Java user group. And also the Pyara Platform Community Survey is still ongoing. I verified this last week with Dominica, and so if you're interested in doing it, please go to that website or scan that QR code. It does take like 5 minutes. So. We are part of the Java community process as a partner member. This was a special thing for Java user groups. We don't have to be elected. And Barry is our individual member representing us in that effort. So, JDK 27. These are the 4 that are now targeted for the upcoming release, which will be in September. 2 more just earlier today went on to the proposed to target phase It's a 1 week review. People can, complain or whatever. They can, if they don't like what they see, then they can provide feedback on that. One of them is Vector API, the 12th incubator. That's a long story in itself. And the other one is, oh no, that's already in there. Don't remember what the other one is at the moment, so I'll update the slides with that. So there'll be probably 6 by this time next week. And to that end, the release schedule for Java 27, June 4th, so just in a couple of weeks. Ramp down phase 1 means that the feature set is frozen. There will be no new JEPs or JEPs, JDK enhancement proposals, at that time. And then from there, it progresses through ramp down phase 2, the release candidates, and on September 14th, Java 27 will be finalized. So. Jakarta EE12, a lot of work has been going on. I really didn't get a chance to update this slide too much. I know they want to look at releasing the core profile sometime later this year. There are 24, and I think it might be 25 now. I got to double check. There might be another spec where the folks they wanted to do some work on that. So yeah, it's going to take some time. It's really like in milestone 6, I think, at this point. We got a couple of new specifications, which is Jakarta Query 1.0. These other ones, so this will be part of the platform. And then the ones you see there, Portlet and Portlet Bridge, they were a carryover from the old Java specification requests. There's initial work to make that transition, so probably won't be part of Jakarta EE12. Maybe 13, who knows. And then the Agentic AI is a new spec as well. I know Reza wants to do a 1.0 very soon. So we'll ask Matt to come down and give his report. So.
Okay, so thanks for allowing me to talk here today. Yeah, it was great to get to go to the Arc of AI. As a student, this is the first time I've ever been to any such convention, and it really turned out to be an amazing thing that I'm glad they have for the professionals, but I also feel like I learned that students do have quite a place and a role to play in these conventions as well. So I hope to personally be back at more of these in the future, and I hope other students are encouraged to do so as well. For those of you that don't know me, like Michael said, I'm Matt Flores. I'm a computer science student here at Drew University. So I'm currently a junior, so next year will be my senior year, my last year here at Drew. But yeah, I hope to use that year, not just academically, but even outside of school, to attend more events like Arc of AI, and hopefully bring more of that back here to you guys. So what was focused at Arc of AI? This is straight from like their website even before the convention began. These are the tracks they focus on, which seem to be very general things. However, I looked at this and thought it was going to be, pretty straightforward. Turns out there's a lot underneath these things to learn from. So the experience for me was a great experience. As some of you who have been here, the Jug can tell, I ran into some familiar faces as well. I was glad to see both Venkat and Frank over there. They were great to talk to. Definitely shout out to Venkat for organizing this event and for coordinating with you guys, for me and then other students from other universities to attend this convention as well. So explain a little bit about how things, evolved. For day one, it started with Venkat just introducing the event, telling everyone about the speakers, how the event was put together, and thanking everyone that helped bring it up. And after that, one of the interesting things Venkat mentioned is that they had given away free tickets for a total of about 30 students to attend this event. However, out of those 30, there were only 12 who actually attended. The even more surprising factor, in my opinion, was that the majority of students who did not attend were all from the same school, and that school was UT Austin. And that's interesting because this was in Austin, so this was like local to them. So, yeah, I learned then that UT Austin students did not show up, and this was probably more convenient for them than anyone because they're local and they don't have to travel as far as me and others did to attend this event. So that was the first thing. As you guys can see, it says Garden State Jug here on the board, so he did acknowledge all you guys for your support. Then we had Baruch and Simon, these two individuals over here that started the initial keynote talk. And as a student, that's where I first felt lost. They went into so much key terms and vocabulary that I personally had not heard of. Some of those words sound like they should be pretty simple, but they're very complicated terms in the world of AI algorithms and all that. So that's when I first had this feeling of like, wow, it looks like in this event I'm not going to learn much because I just don't know what they're talking about. But that was initially. One of the things they did say during the keynote that because it was such a basic example, it was able to stick with me is, by the way, please don't get upset that I've actually never watched the movie Back to the Future, but they use that as a reference. So they I believe it was Baruch that made this example saying that apparently in the movie Back to the Future, I think he said the way that machine works is that you feed it garbage, it creates energy. So the example he gave with AI is this one right here saying that you give it energy and it creates garbage. So that was the example they were using to basically, demonstrate what they were talking about. And this is something that was able to stick to my mind for the rest of the convention because it's pretty simple, even though behind the scenes there's a lot more complicated things in order to understand what this whole concept means. By day 3, things were really picking up. Over here are like the different terms I was hearing over and over again and couldn't quite still understand what does all that mean. Some of them might sound pretty simple, but especially in the context they were used in at this conference, they're not simple. They're actually very complicated terms that I can imagine takes a lot of experience to understand. So by day 3, I was, writing notes. I was making sure I was attending these conferences and writing notes for them. It turns out by the end of the conference, I had, I believe, a total of like 38 pages of notes for the conferences, the talks I had gone to. And what you see here, basically what I just selected have been the most repetitive terms throughout all the talks. And then by day 5, back to Back to the Future, they're dressing up like those characters as you can see over there, giving their talks. So by day 5, which, is the end of it, that's where I'm basically able to at least get some of the terminology and say, okay, I can understand what some of this means even in a very basic way. If you gave me an exam, I probably won't satisfy you with the best definition of these terms.
You'll
but
do fine on the exam.
Yeah, hopefully. But at least I did get, these terms. So that's where, I did realize here's how I'm learning little by little as a student at this event. So the key takeaways, again, this is from my notes. The terms they really try to put into our minds to remember is context is king, meaning that it's all about the context that you're feeding to AI when you're working with it. Trust nothing, verify everything. Kind of relates back to what the example Baruch gave of you give it energy, it creates garbage. You really have to, verify everything, and that goes back to where we have the human in the loop, verifying that everything comes out in the right results. And then AI is great at analysis, weak at judgment. That was another thing really enhanced on throughout the conference. Understanding the strengths and weaknesses of AI. For me as a student though, like a question that kept coming to my mind is a lot of the demos they were doing there involved live coding using things such as Claude Code, which I think is interesting. But at the same time, the questions that kept coming to my mind is, well, what is behind all that Claude code? Like, what is Claude actually coding that makes these programs do such sophisticated things? That's what I was wondering. Apparently that's not a simple question, because everyone I asked that to was explaining that we'd be talking about millions of lines of coding and so many hours that none of us even have to dedicate to explaining or hearing about that. So what I drew is that there's this division between the capability of AI and its limitation. A lot of times they were trying to use phrases like saying AI is actually pretty dumb, not as intelligent as some people think it is. I wanted to see more of that, saying well, where is it dumb? I want to see where AI actually doesn't work so well. So I ended up putting together this AI demo that I'll be showing you guys in a bit. My friend Joey's here, and he actually helped me test this AI a lot, and both me and him witnessed a lot of its dumb failures, and it did make us laugh a lot as we were doing it. We found some interesting things which I will get to later. So when it comes to concerns, something that was brought back up, for those of you that were here at the JUG meeting we had back in February, where Frank, Venkat, they were here. In that meeting, I know there was a lot of questions and answers going about the whole topic of, is AI taking our jobs? And they pretty much gave a pretty clear answer altogether, saying it's not taking our jobs, you still need the humans. The news you hear about large companies firing a lot of people are due to COVID, where they did, they did hire way more than they should have, so now they're faced with that problem of having to clear up that space. Now, to me, that means that there is no concern with AI taking my job, but that doesn't mean that there is no concerns with AI at all. And one topic that I think someone asked Frank at that last meeting was how it's affecting students, and he basically said that it's really affecting students because there are big companies like Google that are hiring some students with great grades and all that. They graduate from schools like Stanford, and then they get to Google and they really just don't know how to code. And now that is a big concerning factor, even if it's not really taking our jobs. For students, this slowly is draining skills, and that is in my opinion a big issue. The one thing that we didn't talk about here, and they didn't talk about at Arc of AI either, is, well, if that is an issue, what are we going to do about it? That's one thing that's really not talked much on. We all can agree it's an issue, but then we can't really think of what we're going to do with that. And
is it because they're using AI in college?
Yeah, well, they're using AI in college, they're using it personally, they're using it for various things, but it's also about the fact that someone raised a good point at Arc of AI, which was another student, I believe he was from Boston University that was there. He mentioned to one of the panels that he's a senior, so he's a grade above me, and he, at his school, apparently was taking this software engineering course like we do offer here. And he said that a big thing he encountered is that he had to show another senior in his class who was also a computer science major what a for loop is. And that's and I reacted the same way. I laughed at that, but then when you pause and think of the serious side, that is really concerning. If you're a senior that's gone through all those classes and levels, and you're actually progressing through every grade, but you don't know how to write a for loop or even explain what it is. So that, I think he brought up a good example of where this is actually causing issues. Now, in my experience with my teachers, for example, talking about AI, I think all of them pretty much agree on one of the statements said before of make AI your assistant, not your replacement. But sometimes even that is not as simple as it sounds, and you have to like show people what exactly does it mean to use AI as my assistant and not my replacement. Where do I draw the line between am I still using AI to learn, or am I just making it do the work for me? That's something that does actually require more in-depth explanation, even though it might sound like it's pretty simple, which I would recommend everyone, it's not just professors, but anyone, when it comes to mentoring younger developers, you show, because it's a simple concept. However, that doesn't mean that everyone will instantly understand what the difference is between using it as a replacement, using it as an assistant. When it came to education, the only talk that really was addressing this like student concern was Frank's talk that was mentored at, it was aimed at mentoring young developers. As you can see, there's his slide saying the best use is as an assistant, not a replacement. So Frank gave this talk. It was in a small room, not many people attended, but the majority of people attending his talk were students. So this is probably the moment that from students we could best engage with at Arc of AI, hearing everything he was saying. I could talk to Frank for hours about how much we agree on like that this is a concern. And he will talk to me as well about like why finding a solution is not that easy, and it's especially because nowadays, you know, being a professor, for example, is not an easy job. Professor Bird knows that. Especially when
extra points.
Yeah, good job. Yeah, it's not an easy job, especially because like when you have classes, like multiple classes with many students, and you just can't really you just really don't have the time to give that one-on-one attention of like, how's the student doing? Are they using AI to learn or not? That really becomes a challenge. So that's another reason why even on the teacher side, solving this issue isn't really as simple as it might sound. So again, that's something that everyone has to work together for in the world of education between students and professors, but even outside education when it just comes to those of us that have more experience mentoring the younger ones. So mentorship, again, as I mentioned, like mentoring I think is like an important thing, and you don't have to be a professor to be a mentor. Anyone can be a mentor. And that's something that I think especially like computer science students really need, and I think it's really hard to find mentorship in this area nowadays. First of all, because availability, a lot of people in this industry are really busy, so there's that. But it's also because when students nowadays seek mentorship, sometimes what they'll explain of what are they looking for, they're looking to grow their skills and experience, but they still don't know how. And the reason is because I think the amount of creativity that you can put into a lot of like programming work nowadays has kind of gone down pretty much all over the country. Even in other schools, when I was assigned programming projects, what I had to do is just follow the instructions. I had to do what that tells me to code and make sure it brings out the expected output. There's not much space there for creativity. So that's something that students are going to want to seek through mentorship, but in order to do that, there has to be mentors out there. So I would encourage you all to approach young developers and then be willing to help them out and guide them, even if it's something that's fully your idea, just for them to get an insight on. And here is an example I like to give. You guys might be wondering why these images. So you'll see this. I've been involved in scouting for a long time, formerly the Boy Scouts of America, now known as Scouting America, for many years. But back in 2023, I joined the Sea Scouts, which is the youth maritime program in the scouting organization. And one of the issues I had fitting in there is I personally didn't really like sailing. And that's pretty much what they're all in for, is sailing. And I personally didn't really like sailing. What I've always liked is aviation. I love flying. I love going out and doing that. That's something I really do enjoy. But Sailing, not as much, but what changed me and made me go from someone that's like in an uncertain position there to feeling very confident and giving it my all as a Sea Scout, it was one of our adult leaders, his name was Mike Taylor. He inspired me just like in a 1-minute conversation. How did he do that? Because he, by the way, is a retired Air Force pilot who flew F-4 Phantoms during the Vietnam era and then went on to fly the F-16. So he understood my love for aviation, and something he told me is, here's all you gotta think of. Just treat the boat's mainsail and jib sail as the wing and aileron of your aircraft. And just by doing that, you're sailing, yet you're becoming a better aviator. And I didn't really that did not occur to me at all on my own, but when he said that, that really changed my entire perspective on sailing. That made me think like, okay, you know what, this boat could capsize, you know, the winds might be strong and fun, they may not be out at all, but as long as I can manipulate this and, you know, get myself used to playing with the wind, I'm just making myself also a better aviator naturally. And now there's a way I can improve without having to spend, you know, $200 per hour of flight. So now I can tell people like, you know, I just became a better aviator today despite not spending a single minute in the air. So even that's a good example for inspiration, like looking to inspire people. Mentorship is a big thing, but if you feel like you don't have the time for mentoring, inspiring is always something that can still change people, and it definitely did to me in this scenario. An inspiration I had at Arc of AI came from Baruch and Victor. I believe a lot of you know Victor because he was here, I believe in March is when he gave a talk here. They both gave a demonstration that inspired what I ended up doing here along with Joey. So this was their setup. Their demo was actually pretty complicated. They connected all these things together. Their purpose was to test, you know, Claude Code versus GitHub Copilot. But the entertaining thing they really created here is that using this camera, they created this face detection system that what it would do is it would detect one of their faces. If it detected, you know, Victor, these bar lights here would turn a certain color. If it detected Baruch, they would turn a different color. And then funny enough, they made it even more advanced by coding it to basically generate a different color depending on what emotion it was sensing in their faces. One very funny experience there is that when they were showing us what each color meant, they said green meant it detects disgust. And at one point, Baruch was trying to make a face to show green, but it wasn't working. And then Victor tells him, no, you know what, just do your normal face. And that detected green. So there's a funny thing in that. But that definitely did inspire me to do the demo I'm going to show you guys. I definitely didn't make it as complicated because I didn't have the time to, you know, bring and put together all this equipment just to show you. So mine isn't as complicated, but hopefully it's as entertaining. So I'm going to go ahead and show you guys the demo here. So I'm going to show it first and then explain it a little bit. So Joey, I'm going to ask that you come down here 1 second to join me for this. I do have to apologize to you guys because of time and now being finals. I did have to do this in Python. I promise I'll do it in Java.
We'll forgive you this time.
Thank you. Okay. So I'm going to run this main here. I'll start first here so it detects my face. So now this program is running. Soon it's going to open up the webcam here. And you're going to see this face detection. Okay, there we go. So here it describes me as unknown, but now if Joey steps in, and he gets a call. Everyone be silent, put this on speaker.
You can remove this message at any time by upgrading to a full account. Hello, Joey_Ricciardi. Hey, Joey Ricciardi. Great to see you stopping by today. Detection indicated that you have IPS. This call is replaced by your facial recognition demo. Goodbye.
All right. so I couldn't detect his emotion, but I could detect him and make sure the program gave him a phone call. So that I hope like just shows you guys what inspired me to pursue these things that AI can do. Obviously this took a lot of coding, a lot of lines. The big debate I was having, I was asking Victor actually for advice on this, and the big debate I was having with him is he was trying to get me to basically say, you know what, just install Claude Code, let it do it for you. And I was telling him, like, that sounds like it'll be very easy, but I want to see this code, I want to see what it can actually do. And he was trying to still convince me to go the other way, because he was saying, well, no, you're going to spend so much hours and stuff, you're not going to want to get yourself into that mess, just use Claude Code. So what I ended up doing to kind of go in between is, by the way, I had never used Claude Code before myself. But I opened Claude, basically told it what I wanted to do, and told it to show me each module it was going to need. And I literally, you know, some people might say this was a waste of time, but I literally like just looked at that and like retyped by hand whatever I was seeing on Claude to at least get the feeling of what exactly am I typing, what's each line of code required for this thing, which did end up taking a lot of hours, but you know, it still achieved a very nice program. Now to indicate what the like encounters of this thing being not so intelligent were, here you're going to see this. So apart from Joey, I had two other volunteers that were in my LLM class with Professor Bird helping me with this program. And these are the two volunteers. This is John and this is David. John and David don't look anything alike, but Professor Bird might recall this. When we tested this on David in class, it thought David was John. And I remember, like, you know, I personally like got a little upset at that, thinking like, why would you think David is John? These two don't look anything alike. Like that, now that can't be called intelligent, right? These guys don't look anything alike. And it was saying that. And then after that class, later that night, I rushed to Joey's suite and said, Joey, we got to do this like on you right now. Why is it thinking this? So first I tested it on myself. By the way, I'm not someone that's in any of these JSON files, so it shouldn't recognize me. And it thought I was 37% Joey. And I was thinking like really? And then it looked at Joey and it thought he was only 17% Joey. And then my friend Sam, who's also Joey's girlfriend, was there too, and I put it on her and it thought she was 47% Joey. And I was, you know, at that point, I kind of knew what was happening, and I explained to Sam that this is how we know AI is being dumb. Because if AI knew what it was saying to us right now, you could literally be dating your own cousin right now. But obviously we know that's not the case, so this shows to you why AI is dumb. So how do we fix all this? Well, what I ended up doing is, in the JSON file for David, there are only 2 photos of him. For John, there's a total of 4, and then for Joey, there's a total of 8. Why does it recognize Joey more than anyone? Because it's been trained the most to understand who Joey is. If I asked John or David to come up here and do that right now, we probably would not see the same result. So that shows you where AI has to be trained, even in things that you could imagine like is pretty straightforward, right? These faces should look different, but it doesn't think so. But we had fun training it. I'm glad Joey helped me with that, and overall you can see this was a fun experience. In case you guys are going to ask me later, like, what libraries and packages did you use, I thought like that would be too much to answer, so I'll just write them out over here. This is everything that was used in that Python program in order to achieve this. And overall, my conclusion of this is that, first of all, what I said at the very beginning, I'm very grateful to have gone to Arc of AI. I really enjoyed that event. I hope to go out to more of these events in the future. It's great to even do this kind of talk to you guys here, explaining what I learned. This is actually fun, and it really actually like brings my joy up when it comes to remembering how grateful I am to be in this world of computer science. I hope that some of you guys learned a thing or two about where the real issue is here. It's not in taking our jobs. I think we can all settle and agree with that, but it might be harming those of us in the process of education. So I hope you all consider, putting your input into what you could do about that. And overall, I do encourage you guys to go to these events as well. There's a lot to learn, coming even from someone that is not a professional and started this event with a lot of unknowns. So that's it for me. Thanks a lot for the time, and I'm going to pass it on to the real speaker of the night.
That was awesome, Matt. Thank you very much. And it's funny, the QCon events by InfoQ haven't done much on Java the last few years. So in QCon London back in March, I walk into the InfoQ editor's room and there's Baruch sitting there. I'm like, oh, hey. So I was a little surprised to see him there, but
That's the last thing I'll just mention. Like, everyone walking around there would identify others by their name tag. When they saw my name tag, they saw that below my name it said Drew University. And the way conversation started with me is people would see that and say, Drew University, do you know someone by the name Barry Bird? So that's how I got to meet people.
that's
What
awesome.
kind of face were they making when they asked that?
The same kind that we did. No, thank you very much, Matt. That was awesome. I'm glad you had a great experience there. So, but and great demos. That's good. That's good. So yeah. So with that, I'm happy to introduce Doug Drexel. Right? Did I say that correct?
Yes.
Yeah. So I've known Doug for a while now.
Yeah.
I was surprised to see him at an Oracle conference about 2 years ago, I think it was. So Doug has worked on many server-side platforms, including Tuxedo and WebLogic Server. I remember those are old names.
Those are all
Yeah.
names. I'm an old guy.
Well, I'm older than you, but
Just barely.
he's currently a developer advocate working with the database team and reaching out to full-stack developers. His most recent work has been with creating servers as a service using Node.js, specifically in the mobile and web use cases. So thanks again, Doug, for coming back. And also a shout out to Mark Nelson, who's here, who's actually presented to us in the past as well. So yeah, thanks for being here. Also, if I may, there are QR codes in 2 spots. Please, if you wouldn't mind, filling out the for attendance, and also put your name in for a chance to win a 1-year license to IntelliJ IDEA. So you can do that between now and when you leave. That'll be awesome. So,
All right, so I work for Oracle. Oracle Database 26AI is a converged database, has a lot of databases rolled in one, and part of my job is showing how you can use that convergence to generate new solutions to problems. So the database, Oracle's always been a relational database, right? But now it's also a vector database, and it's also a geospatial database, and it's also a graph database. And there's innovative ways you could put that together. And this talk came out of a problem company had. It was an ankle monitoring company, right? And they were using the geospatial capabilities of the Oracle database. And anytime a parolee would go out of a geofenced area, they'd get an alert. Parole officer would have to follow up on that. A lot of times it was for stuff that was benign. There was a traffic problem and they got routed around outside the geofence. It would fire an alert, right? They might have to move out and take a detour, and it would fire an alert. And the parole officers would always have to follow up on these alerts. Now, since a lot of these alerts were benign, parole officers were starting to not follow up on them and fill out all the paperwork. So they came to us and they said, well, is there a way that we could take this system and figure out how to distinguish between a benign alert that would never have to be routed to a parole officer and ones that actually need to be looked at? So we looked at a way of where we could build what we called behavior vectors, or vectors that would represent certain types of behavior that could be combined with the geospatial query and would determine if that behavior should trigger an alert or not. So that's basically what this talk is about. All right, So let's put the problem into concrete terms twice. Now, the first one we talked about, parole officer managing 15 cases gets an alert. Subject A just entered a school zone. She pulls it up. He was driving to work at 45 miles per hour, transiting through, not stopping. Meanwhile, subject B has been standing near a playground for 30 minutes. That's the alert she actually needs to act on. On the right, a museum security officer director gets an alert. Visitor A has been in the Monet wing for 20 minutes. He reviews the footage. It's someone sketching in a notebook. Meanwhile, visitor B has been photographing the positions of every security camera in the room. This scenario came from a movie called The Thomas Crown Affair. Both systems fired the same alert for both subjects. The routine event and the genuine threat look identical to geofencing logic. Now notice what these two scenarios have in common, and this is the point of this slide. Completely different domains, completely different data sources, completely different threat models, but the exact same failure mode. The system detects a location event and stops there. There's no way to characterize what the person was doing while they were in that location. So I want to be clear, Oracle Spatial is not the problem here. These capabilities are genuinely battle tested. Point and polygon checks, SDO within distance queries. This is how you answer, is the person inside a restricted zone right now? Our tree indexes make those queries sub-second, even when you're tracking thousands of devices. That 99.9% uptime isn't marketing. Geofencing systems run continuously, and Oracle Spatial handles the load. So when I show you what we're building today, I want you to think of it as a layer on top of this, not a replacement for it. The spatial foundation stays exactly as it is. We're not ripping anything out. The bottom line on this slide is the key framing. These systems are effective at enforcing boundaries. The opportunity is in adding context. The database already knows where everyone is. The question we're adding is, does that event actually matter? That's the problem vector search solves, and that's where we're headed next. The equation on this slide is the whole talk in one frame, and let me walk you through it. Current state, binary logic, in zone equals alert. That's it. The system answers where are they and stops. It has no opinion on whether that location event is routine or dangerous. The missing layer is behavioral context, speed pattern, dwell duration, movement signature. How fast were they moving? How long did they stay? Were they on-road or off-road? Were they near artwork or near cameras? These signals already exist in the data. We just haven't been encoding them in a way the database can reason about. That's what vectors give us. Put those two things together and you get intelligent priority. The system is no longer fires a single alert for every boundary event. It classifies. Routine goes to low priority, risk gets elevated. Now look at the metrics. Greater than 40% reduction in alert volume with 100% true positive retention. That last number is the one that matters. We're not suppressing alerts. We are reordering them. Every genuine threat still gets flagged. What we're eliminating is the noise. So here, we're going to go through these slides. We're going to talk about the architecture, why converging spatial and vector search inside a single database matters, and what that makes possible that a bolt-on approach can't do as cleanly. From there, we'll get into the build. Both parametrics and Argus follow the same three-phase progression. Establish the spatial foundation, add the vector intelligence layer, then combine them into a single hybrid query. We'll walk through both use cases so you can see where they diverge and where they stay identical. The results. the metrics from both systems, and the discussion of why the numbers are different between the two domains. That difference is actually one of the more interesting things in this talk, and how this architecture can be positioned for different use cases. All right, this is the architectural decision, and I want to just cover this a little bit. The traditional approach to combining spatial and vector search is to use the best tool for each job separately. PostGIS for spatial, Pinecone or a similar vector database for similarity search, and then an integration layer. ETL pipelines, sync jobs, APIs to stitch them together and feed a single application. A lot of teams are running exactly this stack right now. The problem isn't that it doesn't work. The problem is what it costs you. You're replicating data across systems, which means you have consistency problems the moment anything updates. Your sync layer becomes a failure point. And critically, you now have multiple security boundaries to manage in law enforcement or museum security. The last one isn't just an operational inconvenience, it's a compliance issue. The Oracle 26AI approach collapses all of that into one system. The geospatial and vector all exist in one database, one query, one security bubble, one transactional context. Here you go. All right, let's look at some SQL. On the left is nothing new. SDO geometry is a native Oracle data type that has existed for years. You create a table with a geometry column. You can hold points, lines, polygons, and then you query it with an SDO within distance. That single line answers, is this GPS coordinate within 914 meters of a restricted zone? This is the proven spatial foundation we talked about. This has existed for a long time. On the right is what 26AI adds, the vector data type. 3 numbers, in this case, speed, dwell time, and road proximity. Stored as a vector 3 float 32 column. And the query operator is a vector distance with cosine similarity. I'm assuming a lot here. So if you guys have a question, please stop me. All right. And we may get into it because I'm going to build out, as we get into the slides, I'm going to build out what a vector space is, what cosine similarity is. We'll talk about this. But this is just an example of the SQL. All right, so here's the thing to notice. There are 2 completely different mathematical operations. One is Euclidean geometry in physical space. The other is cosine similarity in a behavioral feature space. In the traditional approach, those would live in 2 different systems. Here, they are both first-class data types in the same database. Okay, I wanted to say something, but God.
Sorry, I'm distracted.
No, it's all right. I can be distractible all on my own. All right, this diagram is the architectural roadmap for everything we're about to build. 3 layers, each building on the one below it, which is very similar to the problem I started with when we started this discussion, right? They already had the spatial foundation. It worked very well. It processed volumes of data. Layers 2 is where 26AI comes in. We add a vector data type and a behavioral pattern library. Oh, this is what I wanted to say. So what is interesting here, and I think especially for students, this is going to be a simple example of where we're actually building our own vector space and our own vectors in that space to determine behaviors, right? It's going to be very simple. It's going to be 3 data points, but the concepts are going to be the same as if you were building a vector space with 1,000 parameters. This is just an example of maybe where you in the future could decide to build your own vector space, not build on something else in the solutions you build. We add a vector data type and a behavioral pattern library, which you will see. A small table of reference vectors that encode what routine and risky behavior look like in a specific domain. This layer adds context. It answers the what are they doing question that the spatial can't. Layer 3 is the payoff. It's going to be the single SQL statement that combines both spatial containment check and vector similarity search in one query, returning an intelligent priority score in real time. Okay, let's see this. Oh, this is a. Okay, yep. All right, this slide wraps up the architecture section. These are some of the things I alluded to before, right? Because you don't have an ETL pipeline, multiple databases, and all that overhead that comes with it, right? Your performance, you have sub-second latency because there's no cross-system data movement. When your spatial query and your vector query execute inside the same database engine against the same database data, the optimizer can build a single execution plan. You're not waiting on a network round trip to a separate vector store. Security. Parolee location data, museum visitor movement data are sensitive. With a converged architecture, that data never leaves Oracle. No external API calls to a vector service. No replication to a separate system. No second security boundary to audit and certify. And simplicity. One database, one clear query language, one SQL call. Okay, so let's look at the first one, the GPS-based parolee monitoring. This is the outdoor domain. Subjects are carrying ankle monitors that ping their location continuously. Those pings get checked against a set of restricted zones, schools, parks, areas defined by the terms of the parole. The challenge we saw at the start, every ping inside a zone, every ping inside a restricted zone fires an alert. And most of those alerts are routine. Someone driving to work, someone passing through a neighborhood. The officer has to investigate each one, and alert fatigue sets in fast. We're going to build a system that fixes that in 3 phases: spatial foundation, vector intelligence, and hybrid query. By the end of this, we'll have a single SQL statement that not only detects the boundary breach, but tells you whether it's worth waking someone up over it. And the code for all this stuff is in a GitHub repository I'll have at the end. And a lot of this stuff, you do want to play around with it and see like how geospatial works and vector spaces. I mean, Oracle has a great free version right now. It's a Docker container that spins up in no time. You could run all this locally. All right, here you go. This really was the originator of this problem that started this whole presentation. Look at the map on the right. This is the clearest way I can show you what the system sees and what a human analyst would immediately understand. Track A is the green arrow cutting straight through the school zone at 45 miles per hour, one ping inside the boundary, moving fast on a road, gone in seconds. Any officer looking at this map would recognize it instantly as a traffic detour, but the geofencing system doesn't see a traffic detour. It sees a boundary breach, and it fires an alert. Track B is the cluster of red dots in the lower right. That's 30 minutes of pings in the same location, off the road, near a playground. That's the one that needs attention, and it also fires the same alert. An officer gets 2 notifications that look identical. She has to open both, pull the history, check the speed, check the map, fill out the paperwork. The map makes it obvious to a human in seconds. Question we're answering today is how to make it obvious to the database in under 200 milliseconds, automatically at scale, without a human in the loop for every event. All right, so simple. This is really a simple use case. There's 2 tables. That's the entire spatial foundation for parametrics. The first table is restricted zones. This is where We store the areas that matter, schools, parks, any location defined by the parole conditions. The key column is shape, typed as an SDO geometry. That's Oracle's native spatial data type. It can hold a point, a line, or in this case, a polygon representing the boundary of the zone. The second is tracking events. Every ping from an ankle monitor lands here. Parolee ID, timestamp, speed, and location. Also an SDO geometry, but this time a point representing a GPS coordinate. The relationship between these two tables is the SDO within distance operator. That's the spatial join. It answers, is this GPS point within 914 meters of any restricted zone in the polygon? Look at the sequel on the right. This is the actual insert for the Central High School. You're defining the zone as 4 corner coordinates, standard GPS coordinate system. The database stores that polygon natively and indexes it with an R tree, which is why the spatial queries are sub-second, even at scale. All right, and this is the baseline query. This is the stuff that we're building on. This is the stuff that existed before and worked. From tracking events joined to restricted zones, that's the entire geofencing logic. One spatial operator. Look at the result set. Event 1001, parolee 123, Central High School, 45 miles per hour. A boundary breach is detected. The query works exactly as intended. And that's also the problem sitting right there in the result. The system found the event, and the query can't tell the difference between someone driving and someone lingering. So now we're going to build the vector enhancement layer. This is where the intelligence gets added, and it's worth understanding each step because this is the design work that actually matters. Step 1, vectorize the event. You take a GPS track, extract 3 features from it: speed, dwell time, road proximity, and normalize each one to a 0 to 1 scale. You end up getting a track that looks like 0.75 speed, 0.017 dwell, 0.10 proximity after normalization. Step 2 is the pattern library. This is a small table in the database with reference vectors representing known behaviors. What does safe traffic detour look like? Like similar to the face example, except now you're making vectors that are capturing behavior. What does high-risk loitering look like? You define those once, seed them into the database, and they become the reference points everything else gets measured against. Step 3, similarity search. Vector distance with cosine similarity computes the angular distance between the 2 vectors. The closest match tells you the behavior that that set of parameters matches. So what does that look like in space? Well, we can show it here in a vector space, right? So this is a very, because it's 3 dimensions, it's very easy to show, but this is what a vector space looks like. And you have high-risk loitering up there. That's part of already populated in the table by parole officers. Something new comes along that isn't captured into our reference behaviors, they can update the vector space. And you can see the distance between those 2 points and how they map in 3-dimensional space. When you get pings from somebody moving through the area, those GPS pings, you can create your own vector and do a match and find which it relates to. And then use that to determine whether you want to fire off an alert to the parole officer or not. All right, well, let's do a real example. Subject 123 just triggered an SDO within distance alert at Central High. Here's how we compute the behavior vector. Dimension 1, speed. We observed 45 miles per hour. Our maximum expected speed in this context is 60 miles per hour. Anything above that gets capped at 1. 45 divided by 60 gives us the 0.75. The person was moving fast. Dimension 2, dwell duration. How long were they in the zone? 1 minute? Our maximum threshold is 60 minutes. 1 divided by 60 gives us 0.017, essentially 0. They were transitioning through, not stopping. Dimension 3, road proximity. Where in the zone were they? 5 feet from the road center line. Our maximum off-road distance is 50 feet. 5 divided by 50 gives us 0.10. They were on the road. Put these 3 numbers together and you get subject 123's behavioral vector. That's what we're going to query on, right? We're going to query that to all our known behaviors. Here you go. This is one that talks about seeding the reference table. Yes.
Heard the word dwell.
Yeah.
Take me back to the days of automotive treatment systems with points and, some of you, okay, good. Some of you understand what I'm saying. So that would be angle for that, so we're talking the distance or duration, the function of time.
Yes.
Okay.
Yes, sir. Yep. Function of time. How long they dwelled within that restricted zone. Yes. All right. This is the knowledge base, and it's simpler than you might expect. Behavior patterns table has 3 columns, a pattern ID, a description, and a vector describing that pattern. The entire behavioral intelligence of this simple system lives in 2 rows. Pattern 1, the safe traffic detour we just talked about, and pattern 2, the high-risk loitering vector, near zero speed, high dwell, far off road. Look at the table at the bottom. You can see that the contrast between the 2 patterns is stark. They sit at opposite ends of the behavioral space, which is exactly what you want. The further apart your reference patterns are, the more decisive the similarity scores will be. And here you go. This is it. That's the query that defines everything in the one database. No ETL pipeline, no multiple security boundaries, right? You have a single SQL statement, you have your spatial foundation, you have your vector enhancement, one query on whether you're going to fire an alert or not. Well, one query if you're going to wake somebody up. That the spatial, the alert will always get logged, whether it sends a query or not, right? That stuff is never getting lost. And then here's the system making decisions on real events. Right, from similarity scores to intelligent design, parolee 101 and 102 both triggered a geofence breach at Central High School. In the old system, these 2 roles would look identical and both would land on an officer's desk. Parolee 101 matches the safe traffic detour with a score of 0001, essentially 0 cosine distance. It matched our reference pattern almost exactly. So the decision logic was easy: deprioritize, record the event, don't fire an alert. Parolee 102 matches high-risk loitering with a cosine distance of 0.0139. Still low in absolute terms, but the closest match is the risk pattern, and that decision is to elevate. And this is also a way where parolee officers, right? This is another key part of the system that I think should be noted. This is also where parole officers will be able to determine new behavior vectors and refine the system over time, right? Okay. All right. All right. So I think, yeah, so this is, I think from a computer science perspective, this is the most important slide. We just finished building parametrics. We're about to build Argus, but before we do, I want to show you exactly where they're the same and exactly where they differ because that distinction is the entire design lesson. Look at the table row by row. Domain, outdoor GPS, indoor sensor tracking, completely different physical environments. Zone type, restricted areas like schools and parks versus high-value museum galleries, different shapes, different scales, different data sources. Spatial functions, parametrics uses SDO within distance because GPS coordinates have measurement error. You want a buffer. Argus uses SDO inside because indoor sensor grids are precise and the visitor is either in the gallery or they're not. Same Oracle spatial library, different operator. The domain dictated the choice. Now look at the vector dimensions. Dimension 1, speed versus coverage. Completely different signals. Dimension 2, dwell time over 60. Same normalization, same formula. The domain overlap shows up here. Dimension 3, road proximity versus art versus camera ratio. Again, completely different. The bottom line is the thesis. The architecture is the constant. The feature space is the variable. Choosing what to encode and how, that is the domain-specific design decision. And that is kind of almost like a new way of designing software, because now you're designing a vector space for different problem spaces, right? And that's something I think that is going to become more prevalent in the future as we move into our new AI world. All right, so we're going to do this one. We'll go through this one a little quickly because it's the same concept, different problem space. This is the Thomas Crown affair. How do you distinguish between a art fan who is in the gallery browsing through, drawing pictures or working on their drawing, versus someone who's actually scoping out the security of the area, right? And how do you, and again, you want to limit the amount of alerts you send to the security team on what they should follow up on and monitor. All right, so now this time we have 3 tables instead of 2. The third table is where the design difference lives. Monitored zones is a direct parallel to restricted zones. Visitor events is the parallel to tracking events, but then there's zone features, and this is the new table. This table stores the location of individual features inside the gallery. It basically makes the distinction between artwork versus cameras versus exits versus guard stations. Each one is a point geometry. Look at the sequel on the right. We're inserting water lilies by Monet as an artwork point and CAM NW3 as a camera point, both inside the Impressionist wing. Why does this table exist? Because the third dimension of the Argus vector, art versus camera proximity, can't be computed from the visitor's location alone. We need to know what's nearby. That's where SDO_NN comes in. SDO_NN is Oracle's nearest neighbor spatial operator. It answers what is the closest feature to this visitor's current position and what type is it? Is it art or is it a camera? That answer, computed across all pings during a visit, gives us the camera proximity ratio that becomes the dimension 3 of the vector space for this use case. So here's basically, this is just the query in the zone. In this where class, we're using SDO inside, not SDO within distance. That's a deliberate choice driven by the domain. Outdoor GPS tracking has inherent measurement area error. You use a distance buffer to account for that imprecision. Indoor sensor grids don't have that problem. The system knows exactly which gallery a visitor is in. SDO inside gives you a hard boundary. That visitor is either in the polygon or they're not. No buffer needed, no ambiguity. Everything else follows the same structure. Same pipeline. Really don't need to go into this. Same vector space, except we have different labels along the axes. Normalization's a little different. And here's about how we compute a vector. So visitor 4471, impressionist wing, 25-minute visit, 100 sensor pings total. Dimension 1's the coverage pattern. How much of the gallery did they cover? The sensor grid divides the room into 100 cells. Visitor 4471 triggered pings in 45 distinct cells. 45 divided by 100 gives us 0.45, moderate coverage. Not the tight cluster of a casual browser, not the full systemic sweep of someone casing the room. Somewhere in between. Dimension 2, dwell duration. 25 minutes in the impressionist wing. Maximum threshold is 60 minutes. 25 divided by 60 gives us 0.42, moderate dwell. Consistent with someone spending real time in the gallery. Dimension 3, art versus camera. This is where it gets interesting. Of the 100 sensor pings during this visit, SDO-NN determined that 71 of them had a camera or exit as the nearest feature, not artwork. 71 divided by 100 gives us 0.71. That's a high camera proximity ratio. That person was spending a disproportionate amount of time near the security infrastructure. Now think about where that point sits in the 3D space from the previous slide. Coverage is moderate, dwell is moderate, but camera proximity is high. The vector distance is going to tell us that this looks much more like the surveillance behavior than the casual art appreciation. All right, this is again how we would see reference behaviors for this scenario. This is what the query would look like. Again, same kind of stuff, hybrid query. This really is the power right here. It's very simple to maintain a system that's basically a SQL query. And again, similar to what we saw before, here's the result sets. Visitor 4471, closest match is casual gallery browser based on cosine distance on the vector space, and visitor 4472, same gallery, closest match is surveillance casing. Now, look at the note above the flow chart. Closest match determines the response, not the score alone. We're not asking, is this score high or low? We're asking, which known pattern does this behavior most resemble? The decision is classification, not thresholding. If your closest matches the safe pattern, you're routine. If your closest pattern is the risk pattern, you get reviewed regardless of the absolute score value. All right, I don't know, right. I'm not doing the live demonstration because there is a GitHub that can allow you to do all this stuff. And it's easy, really. Now that Oracle has this great Docker container that really spins up in like 10 seconds, and you have a full database. You really do, with vector, geospatial, all this stuff. Scripts are there. All right. Let's say here, I don't know if I'm doing this one, right? Yeah. Yep, these are the results. You'll see the results. All right. And then, you know, I did some tests. I ran some query, 1,000 queries, the whole bit, right? Get the benefits as expected, right? The benefits are different based on different use cases, right? I mean, you know, you're obviously going to get a higher reduction in alert volume because not a lot of people are casing an art museum to take stuff, right? You have more people breaking parole geofences by far. right. Hey, this is what I want to talk about, right? And this is the interesting part too. So this pattern applies broadly. You can take this same pattern and apply it to all different use cases, right? Fleet management, asset tracking, retail analytics. There's all kinds of interesting systems that could be developed using this basic architecture. The secret sauce that any developer would bring to it is how they're going to build their vector space. We made vector spaces very simple for these demonstrations, right? I highly doubt that our real parolee solution is going to be 3 parameters, okay? I don't know how many it's going to be. I can almost guarantee you it's going to be more than 3. All right. So, and what to remember, right? Converged architecture makes it easy, gets rid of a lot of problems when you have to integrate a lot of different databases, a lot of different security issues, a lot of different networking issues, like latency issues. All those things go away from your system. Enhancement, not replacement, right? We built this on top of systems that already exist. Context matters. Real impact, we can prove, at least in our test environments, that there were reductions because of the behavioral vector context, and it's broadly applicable. And you could play with it. So there you go. Thank you. I hope you found some of this to be maybe interesting. Maybe they could think about some different things about what the Oracle database can provide, or different ways to incorporate vectors into your next system. Questions? Yes.
So, for the club, I was storing the source so often of the house. I didn't have direction.
You could. Yeah, you could. You certainly could. And that's why I was saying before about how I highly doubt the real system will have 3 parameters. It was just really, it was just easier to draw, to illustrate a vector space, because you can do it in 3 dimensions. After you get to the 4th dimension, all bets are off. Yeah, sure. Anything else? Yes.
I'm hoping to do business with a company that's ambulance schedule, and which is kind of has a lot of similarities to.
I do. I also feel the same way. I mean, you made me think of something. I gave this talk.
But
Okay, go ahead. Sorry to interrupt.
the geo, where you are is not enough for them. They have to know what the traffic is on the route. When they decide whether this ambulance is just dropping somebody off at the hospital, but is way closer than the other ambulance, but there's traffic.
Right.
And
Yeah, I understand what you're saying. Kind of like Google, when you go on Google Maps and it could show you, sometimes you can make it display real time traffic, red, yellow, or blue, I think it is.
yeah,
Right.
but for example, the guy with the ankle monitor who's going slowly, maybe there's traffic there.
Or is lingering. Right. Maybe there is traffic there. And then the other parameter might be, okay, so he is going slowly because there is traffic there, but we know he's on the road. Right? I mean, there's other parameters there.
Yeah.
And I agree with your point. And like I said to the gentleman back there, I really doubt 3 parameters are going to be it when it goes real.
Yeah.
And I appreciate what you're saying. That's for sure an issue that needs to be looked at. But there is 3 other vectors. So the dwell time would kick up, right? But the road proximity would stay similar.
But unlike
The speed would be low. So you might be able, based on road proximity, to generate another reference vector that would say moving slowly in traffic, but staying on the road.
the ambulance
Yeah,
example,
yeah,
ambulance, they know the start and the end,
right.
but, the ankle monitoring example, no, you don't know where they're going.
Well, we know where they're supposed to go.
Oh, do you? Okay.
Yeah, sometimes you can geofence them, right? And we know where they're not supposed to go. There's two different things. One is like you're in a geofence. My example was, and I learned this as I was talking to these people, but what my example was zones you're not supposed to go near. Like this, I was actually, when we got this, I was actually doing grand jury duty in Newark. So I was learning a lot about things that people aren't supposed to do, right? And a lot of parolees can't go into certain areas. And the school example was because of drugs. Usually, like parolees are out, apparently they don't want them near schools selling drugs. And then I had a boss who said, well, you might want to think about how you show that, because some people could think it's like child predation, which I didn't think. And I was like, you know what? You could be right. I need a different example. And that's how the whole museum example came up. But I wanted to say, I showed this to a group, and a gentleman from Europe said they were going to look to use it to track dementia patients, right? Like, you know, if a mom should get out, but she's in an area you know safe, right? But if that boundary gets breached, it would be alerted to whatever monitoring company they have in the EU for dementia patients. So there's lots of use cases, I think. Lots of interesting ones.
I'm glad your movie example wasn't on that.
Maybe. No. That Tom's Crown Affair, but there you go. So it's kind of interesting. What really, that's what I wanted you to take away is the Oracle database. People think Oracle database is just a relational database. It's not anymore. It's got, there really is so many cool facets. And I hope to be back here to talk about other things I'm working on where I combine property graphs and vectors to generate ontologies for queries on PDF information that you've populated into the database. And there's just so much, and it's so much easier than making pipelines. I don't know, how many guys raise your hands if you've been woken up in the middle of the night because some pipeline broke because the network went down. Right, there you go. There's a man, right? You know what I'm talking about. It's nice if it's all in one database. Yeah, well, yeah, no, it's a pretty good database. It don't break. Well, I don't know if it's broken. Hasn't broken in a while. All right. Well, thanks for your patience. I hope you enjoyed it. I hope you learned something new. Thank you.
All right, good. All right, so just some upcoming events. I really didn't have a chance to really take a look closely at what's coming. I do know that in September is the Kansas City Developer Conference, of course, in Kansas City, Missouri. And I think they have their speaker list all set. I did reach out to Billy about a discount code, if any, if the organizers have one or not. So we'll find out. Let's see. Okay, coming up from us next month, Garima will be giving a talk, I think, on virtual threads, right? Is that what you said earlier today? Yeah, so once I get, all the details, I'll post that on the website, of course, send an email. And then I'd like to do a small update on Jakarta EE12 and what's going on there after that. So that's what's in store for next month. We've been working on getting folks to come visit with us for the rest of the year, so stay tuned for that information. The Friends of Jug, I didn't get a chance to go through what they're doing, so we can ignore this page. The April 2026 winner is Cindy John Bakari. Is Cindy here? I don't. No. Okay. So Cindy won a one-year license to IntelliJ IDEA. So again, as a reminder, if you are interested in that, and also for attendance, we like to talk to our folks about attendance and how many we have at particular meetings, and it's a good thing to keep track, right? Okay, this is just a resources page that you can see on your own. So you can just see all this stuff over here. So, yep, and then here, this is the same QR code that's distributed up in the seats over there. You can take care of that. With that, anything else, Barry? Paul? No? Okay, I think that's it. So, you know, thank you, Doug. Thank you,
Pleasure.
Matt.
Thanks for having me.
Oh, by the way, you said if we have you back, the door's open anytime.
Oh,
Just
thank you.
send me an email and we'll schedule it.
All right,
So,
super.
and
All right,
Mark's the
have a
same
good
thing
one.
for you too. So, but yeah, so thanks a bunch. Safe travels home, folks. It's still daylight, so that's good. And I guess that's more relevant for older folks like me. But yeah, so take care, and we'll see you on June 9th.